Hello. All right, so now we are on question number 3. And we're still on the question with LR, the 62-year-old man who had aggressive non-Hodgkin's lymphoma. I consider this nice that Dr. Tolman did 2 of, oh, huh, the recording has stopped. No, evidently I'm still recording. Okay, uh, so back to where we were. Uh, we are going to find out. The oncologist asks you what is the expected drug concentration after the infusion has run 24 hours and then 1.5 hours after the infusion has stopped. And uh, based on this information provided, we need to calculate the concentration of this drug 1.5 hours after infusion has been stopped. So the information they give us is that our patient is 205 pounds. So we convert that and find that it is 93.18 kilograms. If you don't know how to convert, you just take 205 and divide it by 2.2. All right, and then they give us the body surface area so we can find out our drug dosage. And the way that we find out our drug dosage is we take 5,000 milligrams per meter squared and multiply it by that 2.15 meters squared. And we find that our drug dosage that we need for this particular patient is 10,750 milligrams. Then we also need to find the volume of distribution, which for this patient, it's going to be 93.18 kilograms times 0.65 liters per kilogram. And you find that that is 60.568 liters specific for this patient. So our T half-life is 22 minutes. It's going to run 24 hours. And then it's going to stop. I know you're available. I'm using you right now. Sorry, I'm talking to my computer. Stop after 1.5 hours after this. So the equation that we're going to use to find this is this one right here. So we got to find the rate, we got to find the clearance. Did we have the, no, we do not have the KE, so we have to find the KE. We know the time is equal to 24. We know this difference, the time between the end and the end of the infusion and the time later is 1.5. So we need to find just KE, our rate of infusion, and clearance. So let's do that because we now know what equation we're using. So RO, rate of infusion, that's our variable. So it's been infusing over 24 hours, and so that is 447.9 milligrams per hour. That is our rate. All right, our clearance. Oh, we need to find our rate of elimination first. So conveniently, I have left this space open for it. So you know how to find that. You just take, and this is always in hours, so you have to convert that into hours because they gave us our half-life in minutes. So make sure you guys catch those things, those little things that just trip you up. So now we know that our KE is that. Sorry, I'm trying to remember to label things because I rush through the math and don't necessarily label everything. And we got that from over here, which we found the volume of distribution. We found this over here, and we know that this was running over here for 24 hours. So just so if you lost track because I'm moving too quickly. But you guys can pause this video. What an amazing thing technology is. Oh, you'll find that this is 114.49 liters an hour. That is a 9. Okay, so we now have all the components for this equation. Now we just need to put it all in together and then into our calculator. So I'm going to write out what it all is. So when I first did this, I used to think that because the hours eliminated out, for some reason, that I didn't need to convert them when I first, I thought it was just you could do dose over dose. Not during this class. I know better now because I've taken kinetics before. But for some reason, if you're not very exposed to math as a child, you don't realize that these things are kind of useful and you can't do that. So make sure that you convert those because I'm pretty sure that that's probably how most people missed on it if they did. Now in our equation, I'm just going to point something out. It says T minus T. So we found that our big T is 24 hours. That's the whole entire time that it's been running. Let me draw this out. So that's the whole entire time it's run. And then it stops. So this is big T, and we're expected to find little t. And we're supposed to find the difference between this. Well, this is 24 hours, and they tell us that this difference is 1.5. So what's little t? Well, little t is 25.5. Did we need to find that out? No, because what we needed was the difference between those two. So the difference between those two is 1.5 hours. So we never even needed to do any of that math. So, why is this? I hit something and it has touch enabled. I turn off touch enabled. So you don't need to do that. That's just silly to sit there and add 1.5 and then realize you take away 24 and find 1.5. So none of that is necessary. Save your skin. Oh, come on. Well, this is how you get rid of it. I'm just getting frustrated with my computer. There you go. That's how you erase a huge area of your screen. Alright, so we didn't need to find that. That's what they told us. What time did they stop? How long after the stop time? So you enter that all into your calculator. And so these cancel out, and these do not. These are just normative values. They're just ratios of the amount of drug that should be there, the amount of accumulation, and the rate of elimination. So you find the percentage of the concentration steady state that is accumulated at that point. Are we past 5 half-lives? Yes. So our accumulation is probably pretty close to steady state. So you don't necessarily need that part of the equation, but now you need to know the elimination rate after 1.5 hours. But for posterity's sake, I would say leave in that accumulation part of the equation, and you'll find that is 0.2297 milligrams per liter. Now, let's say we hypothetically took that out. What would you get if we entered that in? So I actually have not done this on my calculator, but I'm pretty sure it's probably really close. So, all All right, our concentration steady state is 447.9 divided by 114.49. So that's our concentration steady state. Okay, so let's multiply that by our elimination rate, which is 9 times 1.5. So what did we find? We found that without this whole entire section, because we're already past that 5 half-lives, we found the exact same answer when we entered all that in. So if you're strapped for time, you could have done that, but many of the people who were probably struggling, they probably did not realize that you didn't need that. Sorry. Out of habit, I just left the accumulation in just because I wanted to make sure that I got the closest to the biggest number. But the issue is, if you want to double check to see if your answer is close, and you know it's past the 5 half-lives, that's one way you can do it. So that's it. I'm gonna erase this line. I don't like it there. All right, so I will proceed on to question 5. We are skipping over question 4 because Dr. Tolman already went through this, and I think I said that in questions number 1 and probably number 2. So now we're going to go to question number 5.